Today we're going to delve into a topic called simplifying radicals. This is all about taking something with a square root sign or a radical symbol and making it into the simplest possible form. Let's get started. So the first thing we really need to talk about is that radical symbol or square root sign is what most people know it as, but it's actually called a radical symbol. Now, the question you have to ask yourself is, what exactly does a square root mean? What is it actually asking you to find? Well, here you go. The square root of some value x is equal to a, where a times a is equal to x. That's sort of the mathematical definition of a square root, real quickly at least. So for example, the square root of 100 is equal to 10 because 10 times 10 is equal to 100. So that's what it means to actually take a square root. Let's look at how we can sort of solve these. So our first example is the square root of 48. Now, there are 3 steps to be able to simplify one of these radicals. Step number 1, find the largest perfect square that will divide evenly into the number under the radical. That number is called the radicand, but the number underneath that radical. So in this case, 48. So hopefully you remember our perfect squares: 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, and 144. Those are the 1 through 12 squares that you should have memorized by now. In this case, if you're looking for 48, the largest perfect square is divisible by 16, and it gives you a whole number back, that 3. So 16 is our largest perfect square. So next, we're going to rewrite the number as a product of 2 radicals, that is, 2 things multiplied together. So the square root of 48 becomes, or is equal to, the square root of 16 times the square root of 3. Now, finally, as we're looking at this from here, is we've got to simplify. Okay, we've got to make it as easy as possible. The square root of 16 times the square root of 3 can be simplified like this. You know that the square root of 16 is 4, but the square root of 3 is a weird decimal, and we don't like decimals. We're going to leave it as a radical. We'd much rather see a radical than a weird, never-ending decimal. So the square root of 48 is equal to 4 times the square root of 3. Let's do another. So the square root of 252, big number here. All we do is we look at our list of perfect squares. So 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144. Hopefully by now you're starting to memorize these even if you didn't even know them before. But rewrite them a few times, you'll memorize these numbers. They're really important. So as we look at these numbers again, we've got to figure out which of these will go into 252. We do a little work back and forth. We figure out that it can be split into the square root of 36 times the square root of 7. So now we've got to simplify. 36 is our perfect square, so that can be simplified to the number 6. Square root of 7 is again one of those oddball decimals, so we're going to leave it as the square root of 7. In the end, the square root of 252 is equal to 6 times the square root of 7. What happens when you don't start out with just a radical, when you have something extra? For example, 3 times the square root of 50. Remember, this is just like regular math. There's a multiplication similar to that we don't generally write down. So 3 times the square root of 50. When we look at our perfect squares, that 1 through 144, 50 can be broken down into square root of 25 and the square root of 2. Our 3 is just going to get carried down. So keep simplifying. we're going to get the square root of 25 turns into just the number 5. We get 3 times 5 times the square root of 2, because square root of 2 can't simplify. So we get 15 times the square root of 2. Since square root of 2 is that decimal, once again, we'll leave it as our radical. We won't simplify it any further. So 3 radical 50 is equal to 15 times the radical of 2. If you were to plug both the left and the right side into a calculator, you'd find that they come out to the exact same value. And that's how we know that we get the correct answers when we simplify like this. So last example, let's check on what happens when we have negatives. In this case, it's going to act just the same. So negative 2 out in front of the square root of 80, it's just like having 3 out front or 5 out front. In this case, it just happens to be negative 2. So we can split 80 into the square root of 16 and the square root of 5. You'll notice as we're doing this, the most important thing is knowing your multiplication tables. That's more important than anything. So 16 becomes 4. Our square root of 5 stays as the square root of 5. And so we get negative 8 times the square root of 5. So negative 2 square root 80 simplifies to negative 8 times the square root of 5. Simplifying radicals is really simple. All you really have to be able to do is look at your perfect squares, think about your multiplication tables, and figure out how you can break products apart, how you're finding factors is what it really comes down to. And we're simplifying all the way down until we can't simplify what's underneath that radical anymore.